Hey everybody. So in our second lesson on relations and functions, we want to kind of dive into the world of what exactly is a function. And then once we figure out what a function is, what do we mean by function notation and how is function notation helpful? Remember yesterday in our intro, I talked to you a little bit about the fact that all I said was function notation was one way of representing a relation. And I said, we just switch y with f of x, okay? And that's really all you know of function notation at the moment. So what we want to do now is we want to dive into why would that even be helpful? Why would we want to do that, okay? But in order to get there, we need to talk about what a function is first, and that's the first thing I want to talk about. So let's get at it. An element we've already talked about in yesterday's lesson. An element is an object within a set, and remember that a set is just a group of elements, okay? The domain refers to the set of the first elements in the relation. It's essentially all the values that x can be. Now we're going to dive into this really deeply tomorrow. Tomorrow is all about domain and range, okay? Then the range is the set of the second elements in the relation, each associated with a particular element from the first set, which was the domain. So essentially the range is everything that y can be, all the values that y can be. Now, I want you comfortable at this point in time, if you hear the word independent variable, or you hear the word input, or x value, or manipulated variable, but those are all the same thing, okay? All of those words mean the same thing. Likewise, I would want you comfortable to say, okay, the dependent variable, that's the same as the output or the y value or the responding variable, okay? Now, here is our definition of a function, and then we're gonna kind of put this into practice as we go, and you'll feel better about it as we do some examples. So a function is a special type of relation where each element in the domain is associated with exactly one element in the range. For every input, there's only one output. In other words, you can't have a duplicate x. Now, we're going to unpack that a little bit, but I want you to understand a couple things before we keep going. All functions are considered relations, okay? Just like all natural numbers are considered integers. You'll remember in a previous unit, we talked about the number families, right? And we talked about the fact that natural numbers were a smaller subset of a larger family called integers. So all naturals were integers, but not all integers were natural, right? We can say the same thing about squares. All squares are rectangles, okay? A square fits the definition of what a rectangle is. The definition of a rectangle is opposite sides are equal and parallel, and all angles are 90 degrees. A square fits that, okay? But a square is a special type of rectangle. So all squares are rectangles, but not all rectangles are squares. Squares, sorry. Okay, in the same way, we have this kind of overarching body called relations. And then we have a special category here called functions. All functions are still relations, but not all relations are functions, okay? Now, a student actually put this to me once, and it was several years ago, and I use it all the time now because I think it's a great analogy. When you're trying to figure out if something is a function or not, think of your input as people and think of your output as houses, okay? When you're looking at this, you'll see what I mean. You can have as many people as you want living in the same house. You can cram them all in, doesn't matter, okay? As many people as you want can live in the same house. But one person cannot be in two different houses at the same time, okay? And that's what we're talking about here, saying you can't have a duplicate x. X can only ever go to one y value. If x goes to two different y values, then it's no longer a function, okay? It's still a relation, but it's no longer a function. So let's see what this looks like. Is the following a function? How do you know? Well, we said we don't want x to be duplicated. Some of you may look right away and say, oh, look, there's a 3 here and there's a 3 here. That's totally okay. What that's saying is person number 2 is trying to live in house 3 and person number 4 is trying to live in house 3. That's okay. We can have as many people living in the same house as we want. When I look at the x's, there are no duplicate x's here. And so that means this guy is for sure a function, okay? So we say, oops, sorry, I didn't mean to go that quick. So we say, yes, it is a function as there are no duplicate inputs. Okay, the next guy, is the following a function? How do you know? Well, I want you to see right away, person number 2 is trying to live in house 10 and house 30 at the same time. So we say that the input of 2 is duplicated. If I was writing this out as points, I have the point 2 comma 10 and 2 comma 30. Okay, so because the 2 gets duplicated, this is not a function. Okay, so we would say, no, it is not a function, as the number 2 maps to both 10 and 30. Okay, how about this guy? Again, doesn't matter. They're all trying to live in house 10. Do you see that? All the y values are 10. That's totally okay. Look at the x's. I've got a 2, a 3, a 4, a 5, and a 6. There is no duplicate x there, so this is a function. Okay. Now, visually, this one might get tricky for a second, but I want you to pick on, let's just pick a point. Let's pick a value for x, okay? I'm gonna say I'm gonna look at when x is 0. Well, when x is 0, I have a y value right there. But when x is 0, I have a y value right there as well. You see that? So right away, the same x is mapping to 2 different y's. So this is not a function because x is duplicated. Okay, so I say this is not a function as there are duplicate x's. When x is 0, there is both a positive and a negative y value. Now, one of the things we do with this is something called, like when we're looking at a visual, when we're looking at a graph, we can perform something called the vertical line test, which is essentially what I just did. Okay, the vertical line test says if you draw a vertical line anywhere along this function, if it hits, sorry, it's not a function, I shouldn't have said anywhere along the function. If you draw a vertical line anywhere along the relation and it hits more than once, see how that hits here and here, or if I did it over here, it would hit here and here. Okay, if it hits more than once, it is not a function because x is being duplicated. Okay, so which of the following are functions? When I look at this guy here, at the bottom, I draw a vertical line right about there and I see it hits 3 times. So that guy's no good. Okay, this guy, draw a vertical line. That was a really bad vertical line, but draw a vertical line and it's okay. It's okay. Anywhere I draw a vertical line here, it's only going to hit once. So this guy is okay. This guy, anywhere I draw a vertical line, it's only going to hit once. That guy's totally okay. And then this last guy here, this is a vertical line. Well, that flies in the face of a vertical line test. So no, that would not be a function. Okay, so the 2 functions are the 2 middle guys here. All right, good. Now, if I gave you the equation y equals 3x plus 5 and asked you to solve for y when x was 3, what would you do? Well, anywhere you saw an x, you would plug in or substitute it with a 3, and then you would just do the math, right? You probably have been, this is called substitution, right? You substitute a number in for a variable, and you've probably been doing that since, I don't know, probably grade 7 or grade 8, okay? So let's try that. I'm gonna substitute in 3 for x, so it's gonna look like this. Wherever I saw an x, I substitute the 3 in there. So I have 3 times 3 plus 5, and that gives me 14. 3 times 3 is 9, and then 9 plus 5 is 14. Now, what does this tell me? It tells me when my input is 3, my output is 14. Okay, it tells me that the point 3 comma 14 lies on the line if I was to draw out this graph. Okay, so all of that should sound vaguely familiar to you. Now, let's talk about function notation. Function notation replaces that y value with f of x. The f represents the name of the function. So we just say this is function f. And it doesn't have to be f. You'll see g of x. You'll see h of x. You'll see j of x. You'll see k of x. You'll see p of x. Okay, there's a bunch of different things you'll see. And then x represents the input value. So f of x means the value of the function at x. Okay, the value of the function at x. So the function's name is f, and I'm looking at it at a particular x value. So y equals 3x plus 5, f of x equals 3x plus 5. That means the exact same thing. Okay, they're just 2 different ways of representing the exact same equation. If you were asked to solve for f of 3, you are being asked To determine the output if the input is 3. Well, that's what I just asked you to do on the previous slide. I gave you the equation y equals 3x plus 5, and I said, hey, figure out y when x is 3. This is saying the exact same thing. F of 3 says anywhere where you see an x, you're going to replace it with 3. Okay, so what would that look like? It would look like this. We'd say f of 3 equals 3 times 3 plus 5, so f of 3 equals 14. Now, why do we like function notation as math people? For a lot of reasons, but the first one is I want you to see that I see my input and my output at the exact same time. I see that my input is 3, my output is 14. That tells me that the point 3, 14 lies on the graph. I don't have to go find that 3 again. It's right there in my answer. Okay, this really confuses students the first little while until they kind of wrap their minds around this, because it's a different context. Okay, if I said they're going to throw their ball over there, you have a visual of what I just said. You understand what I just said. But with the English language, what I just said, I used 3 different theirs, all with a different context. But you've been around the block enough to understand that context, and so you knew which there I was talking about, right? I said they're going to, that's they are. Throw their ball, that's ownership. Over there, that's a place. Okay, but you have worked with those words enough that when you just hear that sentence, you understand the context of what I'm saying. This is why function notation is a little hard at first, because it's a different context for you. Okay, you look at f bracket 3 bracket and you say that is the variable f times the number 3, and it's not. Okay, this is a different context. So don't you dare go dividing both sides by 3 or anything like that to isolate f. That's not what this is saying. This is saying I'm looking at a function. We're going to call that function f, and we're going to look at the output when the input is 3. So by writing it in function notation, it's telling us what our input and our output is at the exact same time. And that's why it's so powerful, okay? But you do have to get comfortable with the fact that it's a different context. It's not a context that you will be as familiar with just at this moment, okay? So this means that when your input is 3, your output will be 14, and it tells you that the point 3, 14 is on the graph. So f of x means f of x, that's what we would say, or f at x. It does not mean 2 variables being multiplied by each other, okay? Stressing the word not. It doesn't mean that, okay? If f is not a variable, but rather the name of the function, you have to be careful that you understand the context, okay? So let's try some. I'm gonna establish f of x as x squared plus 1. And I want you to determine the following. Now, speaking complete sentences at all times. Okay, so f of x, I want to see f of x at the beginning of your statement always, okay? You want an equal sign here, and you want something on the left side and something on the right side at all times. So we go f of x equals 6 squared plus 1. Now, 6 squared is 36, and 1 is 37, so my answer is 37, but here's the point I was trying to make. Don't just say equals 37. What equals 37? It's not good enough that it's right there. Carry it down. Every line should be a complete sentence. It's just all about good communication. So f of x equals 37. Sorry, f of 6. f of 6 equals 37. Okay, f of negative 5, same thing. I'm going to plug negative 5 in for x. So I get negative 5 all squared plus 1. Negative 5 squared is 25. 25 plus 1 is 26. So f of negative 5 is 26. Now, I need to talk about this guy. I want you to determine x if f of x is 10. Now, there's a couple things I want to talk about. First of all, the word determine. The word determine in math means you need to arrive at that conclusion. Unfortunately, I often get kids who will figure out the answer and then they'll plug in the answer to show me that it works. You get nothing for that, okay? I want to be really, really clear with that because you haven't determined anything. You've essentially guessed and checked and then proved that it worked, but that's not what the question's asking you to do. The question's asking you to determine. which means you have to mathematically arrive at that answer. So this is going to involve some algebraic steps, and you have to perform those algebraic steps in order to actually determine the answer. Determine doesn't mean just tell me the right answer. It means find me the right answer, arrive at the right answer. Okay, so that's super, super important. The other thing is, take notice I did not say f of 10 like I did in the first two, right? This says f of 6 and this says f of -5. This says f of x is 10, which means I need to go back up to my original equation, and where I see f of x, the whole thing will get substituted with 10, okay? So what's that going to look like? That's 10 equals x squared plus 1. Now, algebraically, that means I need to subtract 1 from both sides, and that would leave me with 9. Now, I'm looking for a value for x that when I square it, I get 9. You got to be careful with square here, too. There are always two answers to this question. Most of you are going to tell me the answer is 3, and you're going to leave it there. 3 is not the only possibility of a number that when I square it, I would get 9. -3 also works, because -3 times -3 is also positive 9. Okay, so my answer is both +3 and -3. And in math, we can actually write that with a symbol. It looks like a plus and a minus sign right on top of each other like that. Okay, so we say x equals ±3. Okay, so now try again. If you haven't paused me yet, this is a good time to pause me and try yourself. So we're going to go f of 7, which means I'm going to replace x with 7. And I get -5 times 7 plus 11. -5 times 7 is -35. And when I add 11 to it, I get -24. Okay. And then determine x. If f of x is -44, again, that's the same sort of setup where I'm going to replace all of f of x with -44. So I get -44 equals -5x plus 11, and I need to algebraically solve for x. So I'm gonna subtract 11 from both sides, and I'm gonna divide both sides by -5, and that would give me x equals 11. Okay. All right. A person's earnings, S, is a function of how many hours they work each. If a person earns $21.50 an hour, write an equation in function notation to represent their total earnings. So first of all, what's your input and what's the name of the function? Well, we have to talk about that a little bit. First of all, what I want you to read here is a function of. Is a function of, okay? It always goes, y is a function of x, or your output is a function of your input. So as soon as you see the phrase is a function of, what you see to the left of is a function of is your output, and what you see to the right of is a function of would be your input, okay? So for this guy, your S is your output, and your H is your input. If you have letters that have been defined to you, you can't use Y and X anymore. You have to use the letters that were given to you, okay? Again, it's a whole communication thing in math, okay? Half the battle in math is learning how to communicate this beautiful language well, and that's what I'm trying to get you to see. So the name of the function is S, and so in function notation, I'll say S of H, right? Because it's always the name of the function at a particular input, and for this one, your input is H, okay? Now, what would be the equation? Well, you're making $21.50 an hour, so if you work for 1 hour, you get $21.50. If you work for 2 hours, you get $43. How did I do that? Some of you may say I just went $21.50 plus $21.50. Okay, if I work 10 hours, I get $215. What am I doing there? I'm multiplying the amount of hours that I work by the amount I get per hour. So I'm going $21.50 times the amount of hours. So that'd be $21.50 times H, or $21.50H. Okay, so, sorry, I just got to get my mouse back here. So S is a function of H, so it's S of H equals $21.50 times H. I don't need the 0 there because it doesn't do anything in math, but it's not wrong for you to have that if you have that. Okay, now what does S of 40 represent? Now you have to be very, very careful with this. Kids will always tell me, oh, it represents 40 hours. No, it doesn't. S of 40 does not represent 40 hours, okay? S of 40 represents the amount of money you will earn if you work 40 hours. Okay, do you see the subtle difference there? It shows me whether you understand what you're looking at or not. So be super, super careful with that. And don't tell me what it is. I don't want to know what S of 40 is. I want to know what S of 40 represents, okay? So I'm not asking you to answer the question with a number. I'm asking you to give me an explanation. So it's the earnings for 40 hours of work. Okay. The function C of F equals 5 over 9, bracket F minus 32, converts a temperature F, degrees Fahrenheit, to C, degrees Celsius. This is the actual conversion between Fahrenheit and Celsius. Before you could just go to your phone and say, hey, Google, what's 20 degrees Fahrenheit? My phone just went to answer that question, sorry. Before you could do that, you'd actually have to use this formula. So determine C of 50. Well, did I give you an F or did I give you a C of F? I gave you an F. So anywhere where you see F, you're going to replace it with 50. So it's going to look like this. So you'll go 50 minus 32. And then to multiply by the fraction, you can just multiply by 5 and divide by 9. And so you should get a statement that says C of 50 is 10. Now, determine F if C of F is 20. So we're going to go back to the original equation, and where C of F was, I will replace it with 20. So I have 20 equals 5 over 9, bracket F minus 32. Now we have to algebraically solve, remember, because we're asked to determine. So we have to algebraically get F all by itself. This is not a guess or check thing. So I'm going to get rid of that fraction that's on the outside first. So I'm going to get rid of a division of 9 by multiplying both sides by 9. That would give me 180 equals 5 times F minus 32. Now I'll get rid of the 5 by dividing both sides by 5. That would give me 36 equals F minus 32, and then I just have to add 32 degrees to both sides. So I find out that 68 degrees Fahrenheit is the same as 20 degrees Celsius. Okay? Awesome. So here's your mission, should you choose to complete it, and you have to. If you have any questions, please connect with me. And in the meantime, have a great day. Tomorrow we'll talk about domain and range. Take care, guys.